I'm your host, Jim Huseman, and we've got an exciting class for you today over sanitary stainless steel drains and pipe. And presenting is Jimmy Hunt with BLÜCHER Pipe, division of Watts Water Technologies. So yeah, if you have any questions during the course of the class, please use the chat feature at the bottom right of this program. We'll answer each question in turn at the end. And yeah, this is an Ask Me CEU class, so also today I will be sending out CEUs for all the participants today. So without any further delay, I'll pass this on to Jimmy.
Good morning, everybody. Thanks for having us. Thanks for tuning in and paying attention. So today we're going to talk about how informed and intelligent drainage choices promote food safety. So this course is really designed around raising awareness to drainage issues that you may or may not be aware of in your design, just based on standard plumbing codes and how maybe some of those are outdated, and just kind of raise awareness for some of the issues and then propose solutions to mitigate risk of bacteria. So as Jim mentioned, I'm Jimmy Hunt. I'm the Business Development Manager for BLÜCHER, and I'm joined with by Walt C., who is a newly hired Eastern Regional Manager. He's really here for eye candy, but since you can't see him, you'll have to take my word for it. Okay, so today's objectives are to recognize how drainage design can either mitigate risk or contaminate your facility and affect your brand, learn how to specify and manage drains and piping systems to minimize food contamination risks and corrosion issues, and to learn how informed drainage solutions can help mitigate risk of foodborne pathogens in your facility. So, back to raising awareness. Now, all of the data that I'm going to supply for you this morning is all substantiated data from national publications, from the CDC, from the FDA, and all of this data is, like I said, substantiated by these reports and things. I'm going to recognize the reports, but I'm not going to read the entire things to you, but we can supply links and data if you're interested. But this is really about raising awareness of what's going on in the food industry, and this is both food, industrial food processing, breweries, and commercial kitchens, what we're going to address. So these are some statistics: salmonella, bacteria growth, food recalls. This is a bigger problem than it's ever been, and we don't know if it's because there's just more recalls or more bacteria, or if we have better ways of detecting it. So anyway, so that we're want to point out, So this chart here is highlighting basically reasons for food contamination. And what you'll find is the biggest cause for food recall is bacteria. Now, most of you are probably thinking E. coli, but it turns out that Listeria is the most common cause for bacterial growth in food processing. So what happens? CDC released these reports saying that last year, 48 million people were affected with Listeria. Hospitalized 127,000 people and resulted in 3,000 deaths. So this is from bacteria growth in food, mostly caused by Listeria. So what is Listeria? It causes septicemia, meningitis, that one, corneal ulcers, pneumonia, that stuff, spontaneous abortion, stillbirth, physical retardation, and maybe even up to and including death. So that's typically going to be with older patients or younger patients where the immunities aren't as high as a normal adult. So obviously this is an issue. It's created somehow, and we need to figure out how. So when we're working with customers, we want to highlight that not only is bacteria growth bad for their customers, it's also bad for their brand. Everybody's heard of that famous restaurant chain, rhymes with schmushmotle. So that's a real issue, and most everybody on the call has probably heard of this and maybe has a second thought the next time they're pulling into that restaurant. And it's nothing that they did. They weren't doing anything bad. They were following protocols, but unfortunately it resulted in a lot of death and bacteria. So to this point, you can see that not only is it affecting your customer's health, but it's affecting your brand, and that's not good. So what's happened is the the government passed the Food Safety Modernization Act in 2001. Or 2011, excuse me. And what this is meant to do is to design to improve safety through the food chain by preventing contamination. So it's really all about stainless steel. It's about anything the food comes in contact with needs to be sanitary. However, once the food comes in contact with the ground, it doesn't matter. It's trash. They're going to throw it away. So there's no verbiage in the code currently about drains, just about how to clean them properly, but nothing about the way they're made, the way they're designed, and what they're made of. So there's a link there to the FDA. You can get the whole, the act on food safety. So now what they're doing is they're proposing an approved alternative to include drainage. And what this says is they're trying to take steps to prevent the accumulation of standing water in or around drains, because the standing water in your plant can be conductive to contamination with listeria. And steps should include designing and constructing the plant in a way that will make drains function adequately, designing and constructing the plant in a way that will make drains adequately accessible for cleaning, and not installing trench drains in areas where ready-to-eat foods are processed or exposed, and where practical, replacing existing trench drains with enclosed plumbing to floor drain, et cetera, et cetera. So what I want to address here, this is a proposed verbiage to the Act. Now, we're actively promoting against this because what we're trying to avoid is standing water and bacteria growth, right? And that's what we're going to spend the rest of the morning talking about, is the growth of bacteria, how it grows, where it grows, and how to mitigate the risk. So if the most of the water, if you don't have an exposed trench drain that you can adequately clean, most of that water and bacteria and biofilms are going to be produced in the drainage system, which is the pipe, which is underground and not accessible for cleaning. So if you have an area where you're trying to eliminate exposed drainage, then what you're doing is eliminating the possibility to know that you're cleaning it adequately. So we strongly recommend using trench drains as often as you can, because you have exposure to the entire drainage system at that point. And you can know that it's clean because you can visually see it. So for those of you who have designed trench drain before and designed with slot drain, which is a popular drainage solution because it's low profile and it doesn't take up a lot of space, you're not having to worry about open drainage, right? However, what you can't do is confirm completely that drain is clean. There are cleaning tools and things, but you can't verify that the entire drain line is clean. So it's always better to have an exposed trench drain where possible. So now what happens? Now that we're talking about cleaning the trench drain, the Food Safety Modernization Act has highlighted it, but what happened at Chipotle? So you imagine you're in a kitchen and you're cleaning off chickens, say, and chicken giblets fall onto the floor and go into the drain, and you continue doing your job. And then after a while, that stuff starts to dry up, right? And if you're not cleaning it immediately, it starts to dry, it gets stuck in corners or stuck in, the grates or whatever. And if you consider, maybe you've cooked some kind of meal in your kitchen, right, at home, and you leave the pan on the counter for a little bit of time, maybe it's on the counter for an hour or two before you rinse it out. And if you've ever tried to do this and then gone to try to clean it out, you have to scrub, you have to get at it. Especially in the corners, it's really hard to clean out those corners. And if you're considering that same thing in a drain, in a restaurant or a kitchen or a food plant, and that stuff gets caked on there and bacteria grows, and you're trying to scrape it off and you can't quite get at all the corners and edges, and so what you do is you go in with a high-pressure spray and spray those corners, spray the rest of that stuff out. And when you do that, you essentially have created an airborne bacteria. So that's what's happening. That's what happened similar to at Chipotle. It's happening in a lot of food processing plants. They're doing their job and they're following protocol. They just don't have the right drainage design, so you've got a lot of more risk for foods and bacteria to get stuck inside the drain. So the factory floor or a kitchen or even a brewery floor, the factory floor is usually the hottest area, it's the most humid, and if you don't have a hygienically designed system, you're going to have a lot of potential bacteria growth. So addressing the plumbing codes. Now these plumbing codes are a little bit outdated. Yes, they get updated every year, but I want to address a couple of things as it relates to bacteria growth. And mostly to do about biofilms. So biofilms are a big issue, and biofilms are created, that's where bacteria lives, right? That's a breeding ground for bacteria. So how do we eliminate biofilm? So what we've done is we've done exhaustive research on this, trying to figure out where biofilms grow the most. And what we've found is, contrary to our belief, that PVC is actually the most porous material in drainage design, And that's where biofilms are actually created the most because it's so porous. So what this is showing you is that PVC is a little bit better than cast iron, or a little bit worse than cast iron. Cast iron is about the same as asbestos cement, which is a little bit less than galvanized steel, which is a little bit less than stainless steel. So what this is showing you is that stainless steel is the best solution to eliminate biofilm in your drainage design. I think probably everybody knows this, but this is just kind of showing you that PVC is on the opposite spectrum of stainless steel, so you're going to have the most amount of biofilm production in cast iron and PVC. So where's this biofilm coming from? So what happens when we're designing these systems, you're following the Uniform Plumbing Code, you're following the code, but the code is based on curves that were designed when toilets would flush 5-6 gallons a minute or fixture units were flowing more water. And so when you design with a slope based on those curves, you're designing it based on old data. So what's happening now is that hydrogen sulfide gases are being created because the solids in the drainage system are getting stuck because your water flow is such that you're not self-scouring the pipe. So biofilms create, and then the solids, what's the word I'm looking for? Solids will, the bacteria growth, they'll break down, and convert to hydrogen sulfide gas, and so that now is starting to destroy these drainage systems, especially cast iron and PVC. So I'm going to talk about a couple of examples of that a little bit later. But here are the key factors that have shown the responsibility for biofilms. We talked about velocity. Now, velocity, as you know, is created, a combination of slope, a combination of flow, temperature, et cetera. So if we're designing with too low of a slope, we're not self-scouring because low-flow toilets and other fixtures aren't self-scouring the water. There's not enough water flowing through to eliminate these solids. Obviously, temperature, piping materials, bacterial community, and disinfectants. So these things are contributing factors to the failures in these drainage systems. So now, this full disclosure here, stainless steel is not the end-all, be-all, only solution to prevent bacteria. In fact, biofilms can and do get built in stainless steel. We're just suggesting that it's the best solution, not the only solution. Okay, so how this stuff spreads. We already talked about cleaning and corners and edges and cleaning protocols and bacteria and drainage. But there are some other things that we've seen that happen in a drainage system. Now, these are all pictures that we've taken. These are not stock photographs. These are things that we've seen with our own eyes. So what you can see here in this trench drain system, I think this is a cast iron with a poly drain, a cast iron grate. So in a floor of a factory or a kitchen or a brewery, the floor gets hot at times, and the materials of the floor expand and contract at different rates from the steel or the drainage system. So what you can see here on the picture on the left is there's been some deflection in the drainage system. So the drain is separating from the floor. And you have seepage, you'll always have seepage in a drainage system. So what's happened now is because there's separation, that seepage is starting to erode underneath the floor. So the top coat is coming off because all that water from the separation is starting to erode it away. And so now what you have is standing water. We don't want standing water because that's where bacteria grows. So that standing water is now accumulating underneath the floor and underneath the drain. So what's happening now is the drain is, the liquids underneath the drain is starting to erode the floor underneath it. And you can see on the picture on the right, you see more deflection, expansion and contraction, stress cracks in the corner. If you have stress cracks in the corner, you have more standing water opportunity, which we're trying to avoid. A couple other shots. So the picture on the left, you can see that grate is not quite up to snuff, and it's not handling the forklift traffic. And so again, what's happening, even in a stainless steel drain, that there's separation from the floor. You see the separation on both sides of the trench drain. You see deflection inside the drain grate, and it's now starting to collapse on itself. And so again, that liquid is starting to flow underneath the drainage system and starting to erode the floor underneath it. The picture in the middle, I'd like to point out this is a porcelain-lined cast iron sink. This is a very common item. I'm sure most of you have spec'd it on projects in the past. But if you've ever been to a bar or a restaurant, that's a pretty common picture. That drain was installed 18 months before that picture was taken. And you can see that once that enamel, or that porcelain chips off, you have a cast iron floor sink, and it's susceptible to all the corrosion and bacterial growth that a standard cast iron sink might be. The picture on the right is actually a picture at a ready-to-eat foods plant. That was their entire drainage system for 3 process lines. So there was a lot of wet floors when they were cleaning down those 3 process lines. They're making cereal bars, and so they replaced that with a trench drain system. Okay. So are there any questions in the chat currently? We're good? All right, cool. So moving on. So we talked about corners and angles. You see the picture on the left is a standard kitchen channel. You can see that it's sharp corners. You see the edges. We'll go back to the point we were making on where things get stuck and where standing water can be. And standing water is going to be produced in the corners of these things when the floor expands and contracts at a different rate from the steel. Then you'll have that crack and water will start to pool. You see there's sharp corners, there's 90-degree angles, which are very difficult to clean, going back to that pan in your kitchen example. And then the picture on the right is our proposed solution to eliminate all of those issues. So what we've designed is a hygienically designed drainage system to help solve all the problems that we have addressed thus far. We all know that bacteria is an issue. Food recall is an issue, it's a serious issue, and the CDC and the FDA have come out with reports that say that 70% of the root source of the bacteria is in the drain. I'm going to say that again. 70% of the bacteria in these food recalls, the root source is in the drain. And it's because people aren't paying attention to the drain, because it's a drain. Stuff's on the floor, who cares? But between biofilms in the pipe and all the drainage issues we talked about in standard drainage design, that's what's creating all of this bacteria and all these food recalls 70% of the time. So what do we do to solve this? Now, we've come up with this hygienic design system. What you can see, we're going to go through each of the features just to kind of explain how it all gets mitigated. We'll start on the top left. What that option is an extra large filter basket. So you've got an outlet filter. Rather than having a trench drain that has just holes in the bottom of it every so many feet, we have a collection point. And what this does, number one, is you always know where your drain outlet is because it's an independent unit, right? And then what we have is an option for a 2-gallon basket, which you can fill up halfway. You don't have to shut down your process, and you can still have efficient drainage with that extra large basket. So you're not shutting down the process nearly as often. You've got a cast stainless steel grate. That cast grate will withstand, it's a heavy-duty rated, so it will withstand forklift traffic up to 10,000 pounds. It's got raised face on it to prevent slippage, slip resistant. You can see, if you look closely, you can see there are no corners. Everything is rounded, and everything is rounded and smooth, so there's no sharp edges for things to get stuck and create bacteria. You can see on the top right, those are not only support anchors for leveling the trench drain, but they also can be adjusted and molded to act as like fingers in the floor. So when you pour the concrete, the drainage system becomes integrated into the concrete using those finger tabs, for lack of a better word. On the bottom right, what you're seeing is the shoulder of the trench drain is filled with an epoxy. It's an epoxy infill. What this does, number one, is it creates more robust rigidity inside the channel, so you don't have that deflection inside the channel body. But the other thing it does is when a plumber goes in and installs a trench drain, they're supposed to go in and grout underneath the shoulder. Now what that does is prevents any kind of water pooling underneath the drain to create bacteria and standing water. However, most of them don't, or they don't get all the way up in. And as we've mentioned before, in a drain, you're going to have some level of seepage. And so that's where the water is going to pool, is underneath that shoulder. So what we've done is we've included an epoxy infill to prevent that seepage from happening, to prevent pooling water, and to have a more robust shoulder for traffic, for heavy traffic. The other thing that we're seeing on that bottom left picture is the top of that is a blue plastic protective cover. Now this entire system comes with a protective cover around the perimeter and the channel body, so you can prevent construction debris from going into the drain. But what it also does is as you pour the concrete and the adjustable tabs kind of act as fingers in the concrete, that protective blue strip won't get filled in from the concrete. So when you take that strip off, it creates an automatic keyway for the flooring contractor who's going to pour a resonant floor over the concrete. And so that keyway we've created from this protective strip acts as an additional barrier and support inside the trench drain. So now the floor is integrated to the trench drain, is integrated to the concrete. So now it's a part of the floor as opposed to a piece of metal inside the floor, if that makes sense. So we've created a system that becomes a part of the floor. So you're not going to have that separation like we've seen in those other examples. You're not going to have the deflection. You're not going to have all that same seepage and separation. So water's not going to go underneath the drain like it would in a standard system. In the trench drain itself, you can see in the middle photo, you can see how this is designed. What this does is it acts as sort of a funnel. So you see it's more like a kind of a Y shape than it is a standard trough. And what that does is it forces all the solids in your system to go to the bottom. So if you have something going on the floor, anything that falls into that drain is going to go to the bottom of the channel automatically. So it takes a lot less water to flow all of your solids out. So I'm going to show you an example of what that means. But this is going to save an incredible amount of time and labor and water. And then, of course, we talked about corners. We've eliminated all corners in this system, so there's no chance for stress crack, or less chance for stress cracking in your drainage system. So as you can see also that this is what it looks like, sort of an actual photograph on the right of the trench drain system. The drain itself can act as a 90. You can use that as a collection point for 4 different trench drain systems going into one outlet. You can see everything is round. You see there's no specific corners. Everything is tapered round so solids don't get stuck in any corners or edges. And then, of course, we have it as a standard floor drain as well. We talked about it for drains, it's kind of sexy. You can see the top level view of this. It's a cast stainless. You see the basket in there. We've already kind of highlighted some of this, but these are closer images of the rounded corners. Rounded corners, oxymoron, I think. Anyway, so then here's the flow efficiency and design. You can see that. So high-speed channel geometry provides high flow rates at minimal water volumes. Lack of welded corners ensures minimal drag at low flow rates, and we're going to see an example of that, maybe. Okay, so what you're going to see here, you're not going to have any volume, but you don't need it. So what we're seeing here is a standard channel on the left-hand side and a Hygienic Pro channel on the right. So what we're trying to do here is get the solids out as fast as possible with as minimal amount of labor and to prevent any kind of bacterial growth. So what you see is we dropped a bunch of solid particles in both trench drains. The one on the left fell where it fell. The one on the right all fell to the center. So we started flowing about 3 gallons a minute down the drain. And what you're seeing is just even with that low flow of water, after 17 seconds, the entire length of 10 feet of Hygienic Pro is completely void of solids. The one on the left started increasing the flow. You can see solids are still in there. They're stuck in the corners. And we start flowing more and more and eventually flood the entire system. And even after we flooded the drain and the floor, still had solids in there. And so it took 3 minutes and 41 seconds versus 17 seconds, used 25 gallons of water instead of 1 gallon of water to eliminate that 10-foot section of channel. So what this is doing is it's taking less water to clean, it's taking less time to clean, and you're having less chance for bacteria to grow in your system. Okay, so just reiterating back what we talked about, this is a better picture, a more up-close picture of what we were talking on. The circular picture on the top right shows the epoxy infill. It shows the stainless steel kind of fingers on the bottom right, and then that blue plastic protective strip that creates that sort of half-inch rectangle. So that's creating a keyway for the flooring contractor after the concrete has been poured. Now you pull off that blue strip and you've got a keyway around so that the floor adheres to the trench drain, which is adhered to the concrete, so the floor is, again, a part of the drain. The drain is a part of the floor. The different filter basket options we discussed, it depends on the height of the drain. Many of the rest of the world, P-traps aren't required. And so as a result of that, they can have very tall drains because they don't have to deal with the extra depth of the P-trap. So they use in removable traps inside the drain body. And when they do that, they can live with a lot taller drain, which is where some of these different filter basket options come from. Now, I'm not going to show you this video, but it's for most of you who are local, you've all heard of Mad Tree Brewery. They've done a massive expansion here in Cincinnati, and they put in the Blucher Hygienic Pro system, and this is just a testimonial from their key principals talking about why they chose Blucher and what it's done for their process.
You can find it on Disney-McLane's YouTube channel if you want to see it.
Right. It's on Disney-McLane's YouTube. It's on Blucher YouTube, Watt's YouTube. If you can't find it, then you're not looking very hard. It's also on a website I'll lead you to. It's called blucherpipe.com/breweries. All the kind of literature and data you might want to find, you can find it there. If you go to blucherpipe.com/save-water, you can get yourself a T-shirt that says "Save Water, Drink Beer." And it's because using a Hygienic Pro will save 98% of water. Okay, so going into kitchens now. Now, most of you probably have more work in kitchens than you do in food processing plants, but kitchens are basically mini food processing plants. So what I want to talk about here mostly is not just the channel or the drains in the kitchen, because I think most people accept that it's stainless steel, but I want to talk about the pipe inside the system. So this is another example. The picture on the right is a floor sink from Blucher with a split grate, and the one on the left is a 18-month-old enamel cast floor sink. So what I want to point out is both of these things were installed 18 months previous to these pictures. They were both installed in the same building. And you can see the picture on the left. You've got cast iron exposed. It's rusty and nasty, and bacteria can grow inside that drain. The one on the right looks like the day it shipped. So, and the other thing I want to point out is the price is not that different. I think it's negligible. The price difference is negligible between those two systems, and the picture on the right is in stock in North Carolina. So if you're specifying these drains, it's the same price to use a stainless steel floor sink that it is to use the enamel coated. So highly recommend specifying a stainless steel floor sink, even if it's not Blucher. Another thing we run into quite a bit, especially in breweries, and I don't know if you guys do work in breweries, but most breweries will put their drainage or their waste from their fermenters or whatever, they'll put a hose directly into the drain, which is obviously against plumbing code. You need to have an air gap. So we've come up with a solution on the right that clips right onto the grate, and you can put your hose into that funnel, and it creates that air gap. So that's another option for the Hygienic series. You can use it for any of the series, but it was designed specifically for the Hygienic series. Okay, so back to the biofilm stuff and cost of this. So stainless steel is more expensive. We all generally accept this. But it's an interesting article that we read. It says, although the initial upfront cost of purchasing hygienically designed equipment can be more than non-hygienic equipment, the benefits are multitudinous, as well as helping to protect consumer welfare and companies' brand reputations by increasing food safety and reducing the risk of recalls. Hygienic equipment can help with the regulatory, and that's blocked out, analysis and critical control points of HACCP compliance. But investing in hygienically designed product in equipment can also lead to long-term cost savings and increased operational efficiency by allowing run times to be extended, shortening cleaning times, reducing cleaning chemical and water usage, and lowering maintenance costs. So while it's more expensive to buy, over time, it's less expensive to operate and maintain. So we talked about bacteria and biofilms. We've sort of touched on it enough now. I don't think I need to reiterate it, but it is important to note that biofilms have been connected to about 80% of the bacterial infections in the United States, and biofilms grow in wet, damp environments and where there's porous materials. So biofilms grow the most, as I mentioned, in CPVC and cast iron, and they grow the least in stainless steel. So what about cast iron? Now, a lot of major markets will use cast iron still, which is a little bit perplexing because it fails all over the place, but it's cheap. So I want to talk about Blucher stainless steel. It's a push-fit system. This is an analysis done based on average corrosion rates. So all of our pipe is 316 stainless steel, and the corrosion rate, standard corrosion rate, is 1 mil per year under full-time exposure. So assuming the system is exposed to waste and water about 50% of the time, which is pretty reasonable, we're looking at a 78-year product. So when you're buying this stuff, you're buying it for life. It's going to outlive us. By contrast, if you do the same analysis with cast iron, corrosive effect of fluids is almost chromium oxide film. 4-inch cast iron material thickness is 1/4 inch, average corrosion rate of 7 mils per year. Assuming the system is exposed to waste and water 50% of the time, like the analysis on the stainless, then we're looking at a 7-year product. So even the manufacturers of cast iron in general will tell you that it's not, I mean, I'm not saying that it won't work and it has lasted for hundreds of years and we don't know what the difference is. We think that the difference is because of the velocity, because of the design curves that are outdated. And so solids are breaking down in the drainage system and creating hydrogen sulfide gas and mick that is tearing the pipe apart. So this is a couple of examples of things that we've seen of late. This was a casino in Las Vegas. We were minding our own business going to a meeting, and we saw this in the lobby. And we went into the mechanical room, and we saw these guys taking this pipe out. And this pipe was installed 4 years previous to these pictures. And you see some of it has mick on the bottom right, some of it hydrogen sulfide gases that corroded the cast iron altogether. And they're replacing it with cast iron because it's cheap. And they're a casino, and they're going to just relocate or rebuild. But if you want your building to last forever, if you want it to be there forever and not have to ever go through this, then using stainless steel is the right solution. So here's a case study we did. There was a Wendy's in Kenner, Louisiana. This was from January of 2012. So the restaurant was built ground up from scratch in 2006. They noticed that there was a lot of backing up in the floor drains in the kitchen, and so they went to figure out what the source was, and these are the pictures taken on the job site. So you can see where the hydrogen sulfide gases is eaten away on the top of the pipe. Of course, soda water and grease and, clogging of the pipe because you're not heat tracing it naturally, and that stuff just sits and starts to eat away at the pipe, or you get mick corrosion. Another case study in Waterloo, Illinois. So it was built in 1986. By 2001, the kitchen floor was regularly flooded with 2 to 3 inches of water. Upon rotting through clean out, plumber experienced no resistance. So the reason we don't have any pictures here is because there was no pipe left. It totally disintegrated. They had to move down the street. This is an actual case study done by the company listed below. So it's expensive. Stainless steel is expensive. It's definitely more expensive than cast iron. But when we did a case study in the Orleans Parish prison, you can see that Blucher material was $300,000, cast iron was $78,000. So just upfront cost, yes, it's more expensive. It took 800 labor hours to put in Blucher. It took 2,900 hours to put in cast iron. So if you look at a labor rate of $50 an hour, which we all know is pretty unrealistic, in a big market, it's probably more like $75 to $100 an hour, burdened labor, you can see that the differential is not nearly as dramatic. But if you look into a $100 an hour in a major market, same labor rates, or same labor hours, excuse me, it's actually almost the same price to install a push-fit stainless system than it is to install cast iron. So if you're designing a system in a major market, if you consider the labor rates, it may end up being installed cost, may end up actually being the same or less using Blucher. And of course, you're not going to have all that risk and you have an 80-year product versus a 7-year product. However, we figured between 10 and 20% more expensive for stainless steel, which is really not that dramatic if you think about the lifetime cost of ownership. So the other thing is PVC. We've sort of touched on cast iron. We know it's a great product. It works in a lot of applications, but we're finding in food applications it's not the ideal solution because it doesn't like grease, it doesn't like the gases, it doesn't like the sodas and the carbonation. So then about PVC, CPVC and PVC, similar obviously. We don't want to see temperatures over 140 degrees or in CPVC 180 degrees. Your lifetime is half for every 50-degree Fahrenheit increase in water temperature. It starts to soften at 33% of melting temperature. These are statistical facts. This is not our opinion. So we did some more research, and we went to a manufacturer of resin for PVC and CPVC. I will not leave their names in here, but you can find it pretty quickly, and it rhymes with schmoopazole. So what we found on their website is the installation time, how you're supposed to install CPVC. And we all know what's supposed to happen. It's like a 7-step process. Nobody actually follows it, so there's really no reason to talk about it. But on their website, it says when not to use CPVC. And as you can see here, one of the highlights, now there's a lot of areas where not to use CPVC, and this is from the manufacturer, but one of the most interesting things is that it says drains. CPVC should not be used to connect a dishwasher drain to the sanitary drain due to the incompatibility with food oils and surfactants in the dishwasher wastewater. This incompatibility could lead to premature failure in the CPVC. And grease and cooking oils. When CPVC pipe is installed in kitchen areas, the pipe must be protected from contact with grease or cooking oils. Consideration must be given to not only protecting the pipe from direct contact with grease or oil, but also contact that may occur from airborne grease or oil in a kitchen. So the manufacturer of the product is telling you, don't expose this pipe to grease or cooking oils via airborne or direct contact or indirect contact. So if you want to put this stuff in your kitchen, you got to wrap it inside and out. So it's unrealistic, but the manufacturer is telling you not to put it in kitchen drainage. And so what happened was there's a lot of litigation happening around the country in fire protection. These same manufacturers of CPVC for DWV pipe is the same manufacturers making it for fire protection. It's the same basic product. And what's happening is there's been failures all over the country, and most recently a $1 billion lawsuit that was announced in Miami because these high-rise condos, the pipe is failing. And you can tell because you've got water in your ceiling, right? That's how you know it fails. And so what happened was that they found that the cutting oils, the WD-40, the fire stop, the pipe dope, any other things that are in the rest of the system from like cast iron or transitions was getting into the pipe, and it was cracking and corroding. So the plastic pipe is falling apart. So if it's happening in a sprinkler system, it's likely happening underneath the floor because that same stuff is going down the drain, or oils or cutting oils, et cetera. So one of the things, if I can click here, it takes me to that website. So what this is showing you is all of those things that you're not allowed to use in CPVC. You can't have come in contact with any of these products. And I don't know how many of you have done fire stop, fire barrier in your specifications. There's WD-40 on this list. There's pipe dope, cutting oil, any number of products. I think the number is up to 45 now. But this is where you're not supposed to have any of these things come in contact with PVC or CPVC per the manufacturer's recommendation. So take a look at this list and see what you're speccing that may come in contact with CPVC, because it may fail, and that's per the manufacturer. So just real briefly on Blucher pipe as a solution to these problems. It's a lightweight stainless steel. These are some of the applications we recommend for. We recommend for vacuum systems, DWV, food and beverage processing, kitchens, pharmaceutical. And what it is a lightweight 316 stainless steel non-combustible push-fit system. So it's a very thin wall pipe. Just to give you an example, an 8-inch stick of 10 feet of Blucher pipe is about 40 pounds versus an 8-inch stick of cast iron pipe, which is significantly more. You need a couple of people to use it. So it's a push-fit system. You lubricate one end and insert it into the hub and let it dry, and it's not coming apart. We have multiple sealing rings, which are, in essence, there just to keep the pipe together. They're not really intended for any other use. But we have it in temperature ranges of 200 degrees up to 400 degrees Fahrenheit, just in case. We have a transition coupling that's listed for in the UPC for transition from Blucher to cast iron, Blucher to plastic. At some point, the solids or liquids have been diluted enough that you can transition to something that's not stainless steel. Different pipe cutters, you can use a standard old rigid pipe cutter as long as you have a stainless blade. If you're concerned about high pressure situations, the standard pipe as it's designed as a push fit will withstand pressures from 30, it's up there in the 30 to 50 PSI range. We've listed it lower because it's drain, waste, and vent pipes, so it's not relevant. However, if you're in a high-rise situation or you're concerned about pressure, or like when you're taking a turn, we would recommend using a joint clamp, which will hold up to 120 PSI, depending on the size. So then lastly, on the pipe, the other solution we see is welded Schedule 10 stainless. And once you cut a piece of pipe or weld it, if you don't passivate the weld, then it's just as susceptible to corrosion as cast iron or anything else. It takes a lot of time, very special tools and equipment. It's typically about $1,000 a day for a skilled laborer, and a good one, a very, very good skilled laborer at $1,000 an hour can do between 6 and 8 welded joints in a day. And with the Blucher system, the push fit system, we can do 6 to 8 joints in, you know, a few minutes while smoking a joint. So it's a lot easier to do. It's faster. It pays for itself almost immediately, as compared to welded Schedule 10. Is it legal here? I'm sorry. Can I say that?
It's not here.
It's not legal. Sorry, I take it all back. So lastly on this, wanted to talk about, you know, we stand behind the product. Most manufacturers will have a 1-year warranty on their product because, you know, lasts for a year. We're all good. But we've listed and published a 10-year warranty. It's a lifetime product. If you're doing it right, if you're installing it right, it's not going to fail. So we have a 10-year warranty, which mirrors anyone else's 1-year warranty. And we're Watts. We're a part of Watts, which is a well-respected, large organization that has the full support. All right, so that's it. Do we have any questions?
Here's one question. Is there a pressure rating for the push fit connection?
Yeah, we have a listed pressure rating. It's in our technical manual, and the push fit system is rated for 1 bar, which is 13 psi. That's the standard. Put it together, and it'll stay together. It's really difficult to pull apart once you put it together. However, that's what we've published, but we've actually done statistical data analysis, and we've pressure tested this stuff, and I won't publish it for you because we've decided against doing it, but we're talking, some of the pipe was up to 200 psi and it didn't come apart. It's not going to fall apart as long as you have a...
Here's another question. How does expansion compare to other products?
It's minimal. We've done a lot of expansion comparisons. You know, people will put a loop in, or an expansion loop, and they're wanting us to size it, but it's so minimal that we really couldn't run a calculation. And I don't remember off the top of my head what the actual numbers are, and we can make a note and come back to you with the actual answer. But the point is, it's so minimal that we didn't even, when we did the calculations, we didn't even need an expansion loop.
Okay. Any other questions out there? Okay.
I want to just point out a couple other things. Next question typically is, where do I find it? You know, do we have it in stock? How do we get it? And the answer is we stock about $1 million of pipe and fittings and drainage in Spindale, North Carolina, which is east of Asheville. So we're a day away from you or your project, or, you know, depending on where. We also have stock in Reno, Nevada. So we've got bi-coastal stock, if you will, of basically every product that we offer in the United States is stocked in North Carolina and Reno. With the exception of trench drain, that's typically custom made, and that arrives anywhere between 4 and 6 weeks after a release of order. That's pretty typical.
Great. All right. See the other question? What's another question? How does expansion? Oh, we got that.
Yeah, we got that one. Pay attention.
Yeah. All right. Well, thanks, Jimmy, and thank you, Walter, for
you did a great job, Walt.
Yep, yeah, for the great presentation, and thank you all for attending today. I hope you join us next time. It's actually going to be a live presentation in our new wet lab covering backflow prevention, hosted by Brett Mullins. Yeah, it's going to be in our new wet lab. Hope you all can come and attend. It's going to be a fun time. We'll have lunch for you. Yeah, so you should look for that soon for an invite. Thanks again, and I'll get your Ask BCEUs out to you today. Hope you have a good day. Thank you, everybody.
Thanks, everybody.